Hi, welcome to this lesson on risk and precaution. Pause the lesson while you write today's date, title, and do the starter. Okay, so what risks do you take on your journey to school? Well, one of the big ones is the risk of being hit by a car. What you do to prevent that? Looking both ways before crossing the road, making sure that you're not wearing headphones and listening to music that means you can't hear vehicles. Okay, other risks, maybe being attacked by savage dogs. And the way you would avoid that, I guess, is not carrying sausages in your pockets. Okay, there are plenty of other risks that you could have come up with here. Just make sure that for every risk that you've got a precaution that you've taken that has prevented that risk. Right, now with working with that radioactivity, nuclear radiation, so alpha, beta, gamma, is ionizing. That means it can knock electrons off of atoms, and if that happens in your DNA, it can cause mutations. Now, the problem with mutations is that they can cause cancer. So we need to take precautions, and the main precaution we use is to reduce exposure. And we use film badges to check on the amount of exposure to alpha, beta, and gamma. And you can see a diagram there of a film badge, and there are various different levels in front of the film. So in the thinnest bit, all of alpha, beta, and gamma can get through to the film and be detected. In the next section along, alpha is stopped, but beta and gamma can still get through. And then in the final section, only the gamma can get through, and that enables us to see how much of each type of radiation you're exposed to. You can also use lead screening to stop radiation reaching your body, and if you're using highly radioactive substances, use robots. Now you need to know the difference between contamination and irradiation. Contamination is when the radioactive material is on or in you. So the decay continues on or in you. Irradiation is when it's just the radiation coming through you. The irradiated object does not become radioactive. Okay, so the radiation will just pass through you. Right, have a go at the worksheet on contamination and irradiation. Right, so when a person breathes in radon gas, that would be contamination. Clouds containing radioactive materials is irradiation because you're not taking those in or touching them. X-ray scan is irradiation. Radioactive rocks, as long as you're not eating them, is irradiation. Banana as a snack would be contamination because it's going into your body. Radioactive dust caught in your hair is contamination. Injection, contamination. And cosmic rays are a form of irradiation. How much radiation you're exposed to, the radiation dose is measured in a unit called sieverts. There are 1,000 millisieverts to 1 sievert, just like there are 1,000 millimeters to 1 meter. So let's have a look at what our radiation dose is. So my dose from cosmic rays, I live in London, is 0.31 millisieverts per year. I've not been flying at all, so I don't have to add anything for flying. My dose from radon, living in London, is about 0.7 millisieverts. My dose from gamma rays is 0.3 millisieverts. And then the average dose from food per year is 0.25 millisieverts. Then, because I haven't had any chest x-rays or dental x-rays, I don't need to add anything for that. Okay, if I add all those up, that gives me 1.56 millisieverts. Now, if I look in the table, if I'd had any other medical treatments, I'd add that on. Fortunately, I haven't had to, so that's plus 0. The dose I receive from nuclear power is about 0.002 millisieverts. And we're not close enough to a nuclear power plant to get any extra, so if I add that up, my annual dose is 1.562 millisieverts per year. What does that mean? Well, about a millisievert per year is thought to increase the risk of cancer by 1 in 20,000. Lung cancer from smoking is 1 in 200 risk. Similar level of risk, an accident at home is about 1 in 25,000. Murder, 1 in 100,000. So it gives you an idea of just how risky radiation actually is. It's not very risky at all. Right, now take a moment, pause the video and complete the PEQ on radiation dose. Okay, so for 1AI, you should have said this is an electromagnetic wave. For part II, you should have said it can get through because gamma can penetrate the crate or the box or the packaging, or the alpha and beta can't. For part III, the particle is neutrons. BI absorbs or reduces the gamma or the radiation. And then for II, to increase the dose, you either want to slow down the conveyor belt or have the food go around more than once, or stay on the conveyor belt for longer, or have the food closer to the source or radiation. You don't get any marks for talking about a larger dose or using more of the source or using thinner packaging. Then for part CI, how we test it on animals or humans, and we'd look for ill effects and monitor their health, or say that there will be no ill effects. So the first mark is for that idea of testing, and the second mark is for the lack of ill effects on monitoring health. The second part, why would we want to label it? It's so people can make their own decision about eating the treated food or not. You can say it might be against their religious or moral views. You can say that some people prefer food that hasn't been tampered with. You can't get a mark for saying if they don't like the idea of eating treated food. You can, though, say that they don't want to eat treated food. You can't get a mark for saying they might be allergic. That's not affected by radiation. They think it'll give them cancer, also gets them no marks.